Welcome back, pre-calculus. We're in lesson 1.3. We're moving on to example number 2, which starts talking about end behavior. Now, end behavior is something that we did explore in Algebra 2, but we wrote it in a different way. So if you look at this graph here, and I asked you in Algebra 2, how would you express the end behavior? You would say something like, as x approaches negative infinity, comma, f of x approaches positive infinity. And over here on this side, you would say as x approaches positive infinity, in other words, as we start going this direction, my y values start going to negative infinity. So f of x approaches negative infinity. And we're going to say the same thing in pre-calculus, except for we're going to use limits. So this is your first real feel of calculus. Where we start off in calculus is with limits. So you're going to start learning this limit notation, and we'll explore what limits are once you get to calculus next year. So this is what I mean by limits notation. So as x goes to negative infinity, we're going to say the limit as x goes to negative infinity of f of x of my y value is equal to infinity. So this is the limit notation that says the same thing as this guy here. And over here, the limit as x goes to infinity, this piece here, so the limit as x goes into infinity of f of x is equal to negative infinity. So let's try that out on example number 2. So here we have the graph of negative x to the fourth plus 8x cubed plus 3x squared plus 6x minus 80. When you look at this graph, we're going to have two limits, one on the left-hand side, one on the right-hand side. So on the left-hand side is going to be the limit as x approaches negative infinity. So as we go to negative infinity, my y's, so of f of x, is equal to, and then we're going to say where are those y's going to? Well, those y's are going down to negative infinity. If we look on the right-hand side of our graph here, that would be the limit as x approaches infinity of f of x. And where are we headed to on the right-hand side? We're also going down to negative infinity. So down to negative infinity on both sides. Same exact thing that we talked about in Algebra 2, just expressing it a little bit differently to kind of get you more geared towards some calculus notation. All right, see if you can make the leap and do A and B here. Go ahead and pause your video, come back and see if you got it right. All right, here we go. Welcome back. Here is A. As x goes to negative infinity for A, my y values are going to negative infinity. So limit as x goes to negative infinity of f of x, those guys are going to negative infinity. On the right-hand side, as x goes to positive infinity, my y values are going to positive infinity. So the limit as x goes to infinity of f of x is equal to positive infinity. All right, for B, as x goes to negative infinity, y is going to positive infinity. I'm actually going to write it up here because I'm running out of room. So limit as x goes to negative infinity of f of x is equal to positive infinity. And for the right-hand side over here, the limit as x goes to infinity of f of x, now my y's are going down to negative infinity. And that's it for example number 1. Like I said, it's just like we've done before in Algebra 2, just with a little bit of a pre-calculus, calculus spin on it with this limit notation that we'll explore in greater detail later.